My goal today is to cover section 3.1. That's for your test. I want to get it finished about 10 minutes before the end so we can talk about your test and test 2. So here are a bunch of questions. I picked them as a kind of good kind of cross section of the types of things that you see in 13.1. I'm going to start off with a relatively straightforward one. In fact, I would say a very straightforward one. Okay, we're using a shortcut method. It's called the chain rule. Basically, as long as the thing is written as a power of whatever the variable is, in this case Z, you can use the power rule, which is multiply by the power and reduce the power by 1. Multiply by the power and reduce the power by 1. And that is the derivative. Finished. Some questions, you don't need to change the guy to differentiate it, and the answer is good the way it's written. However, that's not always going to be the case. In this function here, we need to do some work. You cannot differentiate 1 over t or 1 over t to the 6 if you leave it in that format. It just doesn't work. Don't we have to turn both of these into powers of t? 1 over t is t to the negative 1, and 1 over t to the 6 is t to the negative 6. Are we comfortable now with that algebra that 1 over something is the same as its negative power? Once it's written like that, now we can differentiate. And we just do the power rule. Multiply by the power and reduce the power by 1. Multiply by the power and reduce the power by 1. And then we do style points. You should always write your answer, your derivative in this case, so that it looks like the original. So this question should be written as negative 1 over t squared and negative 6 over t to the 7. And here we're using the property that we used here, but we're using it in reverse. And what that says is a negative power can be written as 1 over a positive, and negative power can be written as 1 over positive. And we are now finished. And here's question 12. We're going to differentiate this guy. Okay, you cannot differentiate this guy the way he's written. Don't we have to write him as individual, separate powers of x? So how's that going to work?
Could you just distribute the x cubed?
That's what I would do, yeah. X cubed times x, x to the 4, x cubed times 4, 4x cubed. Now I can differentiate. Multiply by the power, reduce it by 1. Multiply by the power, reduce it by 1. And that's the answer. And I would accept that. I'm quite happy with that answer right now. Maybe in a few weeks from now, I won't be. In a few weeks from now, I'll expect you to do that. But right now, I'm not bothered. You agree you could factor it. There are 3 rules to the style points. The only one that we're really sticking to right now is make the answer look like the original. Right, that's why we had to do this and this, right? The other 2 rules are collect like terms and factor the heck out of it. This would be factor the heck out of it. Those 2 rules were not implementing right now. So you just need to focus on making it look like whatever the original question looks like, and that's all. So next guy on the list is like question 15 in the homework. This one is messy and does require a fair amount of algebra and a lot of being careful. You might think, what is he talking about? I am going to fix this fraction and convert it into individual powers of x's. And if that 3 wasn't there, wouldn't one of the ways I could do that would be just to multiply the top by x to the minus 2. Agreed? So I could take the top, the numerator, and just multiply it by x to the negative 2. But it isn't just x squared on the bottom. It is 3x squared on the bottom. And a lot of people think that that means that this fella here is 3x to the negative 2, but he's not. If you cover up that x squared, isn't that 3 essentially a third? It's a 3 on the bottom. And algebraically, a lot of people make that mistake. They think that this 3 and this guy are like stuck together with super glue. And if you move the x, you have to move the 3. It's not actually the case. Do you see how awkward that one was because of that? It's dead easy to think it should be 3x to the negative 2, when in fact it's a third x to the negative 2. That's just a little algebra thing you just have to be aware of. Hopefully you won't get to do it very many times, but for the few times you do it, you need to know it. Now, I should have, but I forgot to, so I'm now fixing it. Shouldn't I also, while I was at that, turn the square root into a half power? Agreed? Square of x isn't any good. I need a half power. Now I can distribute. This guy times this gets you the very ugly 5/3, and the powers when you combine them are positive, no, sorry, not positive, negative 3/2. And this guy times this, well, you get 3, so I guess that's something, and you get a negative 1 power. So after all that work, all we've really got to is the point where we can now use the power rule. But I haven't actually differentiated in it yet. I've just written it in a way that allows me to differentiate it. So it's derivative, multiply by the power, and reduce the power by 1. Multiply by the power, and reduce the power by 1. If you're wondering how 5/3 timed it, ended up as negative 5/2, if you take 5/3 and you multiply it by that guy, the power, and the 3's cancel out and you get negative 5/2, right? So that's where that came from. Do you think I'm going to let this answer slide? Is that going to be the style point answer for this question? Well, look at the original. Do you think that fits the original look? No. So you kind of know that you're going to have to fix it. Let's fix this one because he's the easiest. Let's try and fix this one. Well, that's a little bit better, right? But 5/2, it's not going to cut it. Not this time. Doesn't the original have square roots in it? Doesn't have fractional powers, right? Has square roots in it. So I need to take this horrible thing and turn it into that over that. We're now finished. Are we good with that one? The most likely place I think a mistake's going to happen is probably right there. Because people will call it 3x to the negative 2 and not a third. So hopefully I've emphasized that enough so that you won't do that. That's an ugly, ugly looking answer. Right, this one here, 16, has one major problem. And it might not even look like a problem. It's easy to overlook it. I definitely can't differentiate this because I need to turn them into powers of t, right? I'm going to take care of this fella first. That is not really much of a problem. This innocuous looking square root of 2t is a problem. May not look like it's a problem, but yes. Because I'm going to have to split them into that. And then I'm going to have to call them that. Do you notice that the 2 and the t have to get separated? Because the power rule only works with x to a fractional power, t to a fractional power, not 2t to the power of half, but only t to the power of half, right? You got to separate out the constant. And that's what made that question so tricky. It was just this 2 being inside the same square root as the t. Now, we are good to go. Multiply by the power and reduce the power by 1. Multiply by the power and reduce the power by 1. Right? Chain rule, I keep counting chain rule, the power rule. That in itself, this guy here, can now be written as that guy, and this guy can be written as that guy. And I have this guy, and I have this guy. Is there anything that you think could be made a little bit prettier?
Move the 2 to the bottom.
Call it good? Would you agree that looks a little bit prettier? Sabrina, you're looking like you don't like that. Is it okay?
No, it's fine.
You happy?
Yeah. It was a little small on my screen. I was
Okay.
just checking.
Oh, it's just sight. Okay, I hear you. Right, last guy, and then we move on to equations of tangent and normal lines. So this is like question 19. And we have this guy. We have this guy over this guy. I can tackle this, yeah, I can do this question at least 2 different ways, both work. Anybody got an idea of how to get this thing into a form that we can start differentiating? As I say, there's 2 different ways I can think of doing it. You might come up with a third one, that'd be great. Any suggestions? None?
Well, you can.
What's the
turn-
problem? I guess if we identify the problem, maybe we can figure out a solution. So what is the problem? Why can't I just start doing what I need to do?
I think it's because there's a v in the exponential.
That line is on top.
Yeah, I agree. You know, that V's causing trouble, right? This V in the bottom, I mean, that's causing problems a little bit, but the V in the bottom is a major problem. How could you fix it then, now that we've identified the guy that's causing the trouble?
Can you just multiply it all by V?
Almost, you can multiply it all by something, but it's not V, but V to the -1, right? If it was V squared in the bottom, wouldn't you multiply everybody by V to the -2? If it was the square root of V in the bottom, I guess you multiply everybody by V to the -1/2. Now, I should have, and I forgot to do this, I should have converted that into that fella as well. Okay, this fella times this fella gets you V to the -2/3. Oh, that's a fun thing. What happens when you multiply -5V e to the V by V to the -1? What do you get when you multiply those two together? Something really nice happens.
The V just disappears.
Yeah. If you're interested, what was my other method? You know, my other method would be to divide these two and divide these two. In other words, separate them into two distinct fractions, and you would have ended up at the same place. Right, now, all we've done here is set it up. Now we differentiate it. Multiply by the power and reduce the power by 1. And I like this guy, because differentiating 5e to the v just gives you -5e to the v. Now it's style points. Bring the guy downstairs and then turn him into a radical. I think I'll rewrite that again. It looks weird. Yeah, looks a little bit better. There we go. And there's our answer. We have differentiated that horrible expression. Okay, let's move on then. Next question is not that one.
Could you bring that last
Question
problem back
21.
just for a second longer? I didn't get the chance to finish.
Sure.
Thank you.
Yeah. Right. While you're doing that, the next thing that we are going to be dealing with is equations of tangent lines, which we've done before, and equations of normal lines, which we haven't done before. So we're going to find out how to find equations of tangent lines and equations of normal lines. By the way, that line and that line's the same line. I just wanted to write it again because it looked ugly. So you don't need to write that line. Are we good? Right. Okay. Question 21. Better hide that because it's actually, yeah, I've best hide it. Y equals 2x cubed, take away x squared plus 2. And we are being asked to find the equation of the tangent line to this cubic at the point 2, 14. So equation of tangent line. First thing you're going to do is find the derivative. In this case, it's good to go, power rule. Multiply by power, reduce it by 1. Multiply by the power, reduce it by 1. You don't get anything for that guy. And that's step 1 done. Step 2 is we find the slope of the tangent line, which we call m. And you get that by evaluating the derivative at x equals 2. So I know this is the derivative function. If I find out what the derivative is when x equals 2, I get 6 lots of 2 squared, take away 2 lots of 2, and that ends up being 20. And then we move on to step 3. We find the equation of the tangent line. Well, if you know that the slope is 20 and that the line passes through the point 214, we typically call this guy x1 and y1, and the equation that you're always going to use to find equations of tangent lines is called the point slope equation, which is this one. In this case, y take away 14 equals 20 x take away 2. If you distribute the 20, you get 20x take away 40. And then if you add 14 to both sides, you get that. So finding an equation in a tangent line has really got 3 stages. Find the derivative. That may or may not be easy. You may have to do work, but you'll eventually get it. Find the slope of the tangent line m by evaluating this derivative at the x coordinate of the point of interest, in this case 2. We've got 20 here. And then you take the slope, which is 20, and the point, in this case 214, and you use it in the points slope equation, and you're done. Pretty straightforward process, right? A 1, 2, 3. Let's do one more of these. The next equation is question 24, or at least like it. And it's y equals x plus 4 over x, and it's at the point 4, 5. Okay, now in this question, I did have, I know it's not a lot of work, but I did have a little bit of preparation to do. You have to call 4 over x, 4x to negative 1. Now I can do step 1, the derivative. That guy gets you 1, multiplied by the power, and reduce it by 1. And that gets me 4 over x squared. Now, step 2 is we find the slope of the tangent line m, and it's going to be the value of the derivative at, in this case, at x equals 4. So it is 1, take away 4 over 4 squared, which ends up being 3/4. And then the final stage is to find the equation of the tangent line. And we know in this case that the slope is 3/4, and we know that the point is that guy. So it's going to be x1, that's going to be y1. And the point slope equation then that we use is this guy. Y take away 5, 3/4, let's take away 4. Distribute the 3/4 and add 5 to both sides. And there is the equation of our tangent line. Now, in a normal WebAssign question, couldn't you just type the answer in and it'll do the big green tick and you know you're correct? But imagine you were doing it in a test. You could simply just go to Desmos and type in this guy, and let's pretend that's what that guy looks like. And if you put the equation in and it works, what you'll see is a perfect tangent line at the point 4,5, right? That's what it'll look like if you did it right. If you screw up, won't your tangent line be down here somewhere or up here somewhere, or God forbid, cut through the shape in some way? Won't it not be a tangent line? It'll be screwed up in some way. And so that's a very quick check. It only takes a minute or so, isn't it? You can plug in, you know, this guy and then plug in this guy, and if they match, you are good. I'll put that over here in case you need to catch up. So what we're going to look at now is called a normal line. So we're going to find the equation of a normal line. And there's a few questions in the homework where you're asked to find the equation of the tangent line and the equation of the normal line. So let's try and kind of describe what a normal line looks like. Imagine this is y equals f of x, and imagine that we're interested at this point here. We'll call it P. We know visually what a tangent line looks like. It'd probably be this line here, right? And we get the equation of it, and that might be the equation of this tangent line. A normal line goes this way. And a normal line is at right angles, perpendicular is the word we like to use, at right angles to the tangent line. And we are going to find the equation of that green line. Now, it passes through the same point, right? It just doesn't have the same gradient, right? If this gradient is 2, that's definitely not 2, right? So how do we find the slope of the normal line? Because if we know the slope of the normal line, can't we now say the slope is this number, it passes through this point, and then we just use this equation, right? Well, here is the property that we're going to use. The product of the slopes of a tangent line and a normal line always equals -1. So if you imagine that the slope of this tangent line is called M, and that the slope of this normal line will use the letter N, what I've just said here is that M times N will always equal -1. So you might say, well, how does that help me get the slope of a normal line? It actually does. If the slope of the tangent line is 4/5, the slope of the normal line ends up being -5/4. If the slope of this guy is 3, the normal will be -1/3. If the slope of this guy is -7/5, the normal is +5/7. If you look at these 3 examples, do you see that there is a clear connection between the 2 numbers or the 2 fractions? And if you multiply them together, can you trust me, they all come to -1? But there is an even quicker way of doing that. This is just a made up name. it's a negative reciprocal. What that means is turn me upside down and make me a negative. Turn me upside down and make me a negative. Turn me upside down and make me a negative. Okay, well, a negative of something that's already negative becomes positive. So in the question that we just finished doing, this one here, let's imagine that they also asked for the equation of the normal line. Well, I don't need to do too much extra work. The slope of the tangent line was 3/4. What's the slope of the normal line? One of them is
Negative.
3/4. Negative.
Negative 4/3.
So, yeah. Do you see what I mean about negative and reciprocal? Turn me upside down. Well, I know everything I need to know now to get the equation of the normal line. Don't I know its slope is negative 4/3, and it passes through the same point as the original one does. So there's my x1 and my y1. I'm going to call this m again, because that's what we use in our formula. So the point slope equation is y take away 5 is negative 4/3 x take away 4. Distribute that guy and you get negative 4/3 x plus 16/3. If you add 5 to both sides, you're basically adding 15/3. So you check that, but there's your answer. So if you want to find the equation of a normal line, all you need to do is find out what its slope is and use the point slope equation, just in the same way you use the point slope equation to get the equation of a tangent line. I mean, the only difference between these two is the slope that you use. And this guy is just going to be the negative reciprocal of that one. Have we any questions on that before we move on to the last part of today, which is talking about your test? Okay. A few seconds to get things going here. Good, good, right. I hope you are now looking at our Canvas site. I've got it on student view, so it should look pretty much like this when you do it. Maybe make it a little bit bigger for those who've got smaller screens. Right, looks something like that, right? It's already got the information that you need. Most of it you've seen before, but there is one difference. If you click on the top link, what you need to know, and I'll put it on full screen and make it a little bit bigger. I've essentially put up here everything you need to know for your test 2. So test 2 will be on Canvas. It'll be visible at 9, it'll close at 10. If 9-10 slot doesn't work for you, you contact me and we'll figure out another time for you to do it, right? Typically, you might do the 8 to 9 slot. That's the most common. Now, this test will cover 4 sections. Section 2.6, the limits at infinity. Can you remember the limit as x tends to infinity of ugly fraction, that kind of stuff? And the limit as x tends to 4 for a vertical asymptote, right? That's those questions. 2.7, derivatives as rate of change. That's the limit as h tends to 0 or the limit as x tends to a. You know, the ones where you have to fight your way through, you know, the 15-minute question kind of deal, those ones. It also includes questions where they ask you to find the instantaneous velocity, because instantaneous velocity is just the derivative of a distance time graph. 2(8) derivatives of a function. That's where you're given f of x and you try and draw a sketch of what its derivative would look like. And lastly, what we've done today, using the shortcut, which in our case is the power rule, to find the derivative. And maybe the equation of a tangent line and or a normal line. And there are going to be 4 questions. So it won't surprise you to know you're getting 1 question from each section. But not all questions are equal. They're not all going to be 25 points each. Some questions are going to be worth a lot more than that. Can you imagine the one that asks you to draw the sketch of a derivative probably won't be near as many points as some of the other things. And I'll tell you what these questions are worth anyway. Now you know that your test will be on Canvas as a PDF, just like last time. There's going to be a Zoom meeting. Turn up, have your video going. Here's the link. What you're not allowed to do, you're not allowed to talk to or communicate with any human being, living or dead, by person or virtually. So you're not allowed to email them, blog them, instant message them. I haven't time to go through every physical way or virtual way that you can communicate. Don't use a Ouija board to contact the dead. I mean, just don't communicate with anybody, bottom line, virtually or otherwise. You are not allowed to use sophisticated software either. But you are, excuse me, you are allowed to use Desmos, and you are allowed to use any notes that you've written. And nothing wrong with that. And you can use your calculator. But bear in mind that if you have 40 pages of notes and you think, well, I don't need to learn anything, I just need to write it down in notes and find the right one, you'll never get the test done in time. You just spend far too long looking up stuff. So be careful about your time management. Okay, when you're finished, you're going to do all the good stuff. Let's go back out and show you what that's going to look like. There's Adobe Scan. Upload your canvas and so on. Okay, so you're going to take pictures of your work and you're going to upload it into Canvas. Let's show you here will be eventually where test 2 is. It's obviously not here right now, but it will be. And when you do the test, all of Canvas will disappear except test 2, and all of WebAssign homework questions will disappear. And you've done your stuff, and you click on here, and you start the assignment, and you choose a file, and you pick your working, which is a PDF, and you hit open, and then you submit it. That's pretty much all you need to do to set up your working. What else? Don't know. Is there any more questions?
So the link for the Zoom
Will
meeting,
you?
is there just that one link?
Yes.
Because I remember last time we had a test, I got like 2 different messages in Canvas with 2 different links. So I was kind of just sitting in one hope.
I've just made one link this time to save that issue.
Okay.
And So the one link or the two links might have been also because I had other people coming in from a different class, and so I was sending them the information, but I probably sent more people than needed to know the second link, probably.
Okay.
So you just hang on with that link and you should be fine. And once you've done, yeah, you know, if you finished in 40 minutes and you've done the stuff and I've checked that it's in Canvas, that's the last thing I need to do, then you're done, right? You're finished. Err on the side of safety. Always show working, even if you think it's not that relevant. There are exceptions to things. Do you know the one where you draw the graph of the derivative function? I'm not sure there's working for that, but isn't there little dotted lines that you have to draw and little shady things that you probably want to shade? So I'd keep them in as well, just so I can kind of get an idea of what you're doing, especially if you make a mistake. At least I can see if it's a little mistake or a big mistake. Say hi. And bye-bye then. Any questions? Any more questions? Right, so